Hello everyone. Today we are going to solve this problem which was asked in JEE Advanced 2023. Most people solve this problem by using complex number and roots of unity. Those methods are elegant, no doubt. But those methods often rely on a very sharp observation at just the right moment. But what if I told you there is another way? A way that doesn't rely on a sudden flash of insight, but instead the way unfolds naturally, step by step. In this video, we will solve this problem using trigonometry. You heard right. We will use trigonometry to solve this problem, which is built on intuition and geometry. What we can see, it is hidden in the problem. I admit it's not the fastest solution I'm going to present, but it's deeply satisfying, completely rigorous mathematically, and honestly quite beautiful. Because mathematics is not always about the speed. Sometimes it's about understanding, about seeing the same reality from a different lens. And if you are someone who enjoys exploring multiple approaches to the same truth, this might give you an intellectual thrill. Let's dive in. So before you see the solution ahead, I request you to solve the problem in any other way so that you can also understand the way I'm going to present. The question is that let A1, A2, A3 up to A8 be the vertices of a regular octagon that lie on a circle of radius 2. Let P be a point on the circle, and let PAI denote the distance between the points P and AI for I goes from 1 to 8. If P varies over the circle, then the maximum value of the product PA1 till PA8. We have to find out the maximum value of the product of these things. So first, let's understand the geometry of this problem. So I have already made this picture in GeoGebra so that my handwritten or hand-drawn figure will not hinder the concept. So the idea is this. This question was solved with a complex number also, but I'm going to present the solution with trigonometry. So what I'm suggesting is that, please understand, the thing is we have to choose any point over this circle. So how do we understand that where we choose the point P so that the product will be the maximum? So of course, any point P we cannot choose at any given vertex of this octagon. Otherwise, the distance between the P and the vertex itself becomes 0, and that will become the minimum value, which was not intention of the question. So of course, if I choose the P anywhere on this arc, and wherever you choose, means whatever arc you choose to choose the point P on, that point will be symmetrical about any of the position from the center. It means it doesn't matter where you choose the point P to solve this problem. Now, somehow you can understand by the symmetry that the point P, if you choose exact symmetrical at this angle, means it is actually bisecting this chord or this arc, that point P should give the maximum product. But let's don't assume this thing, and let's assume that there is some point P not exact symmetrical about that. So we'll choose somewhere. So let's choose this point P over here. I'm choosing this point P here. It doesn't matter you choose this arc or that arc, but that arc is close to the x-axis, so it will be easy to assume theta or the angle. And now notice one thing, that if I join this O to A2 or any of this, that will give you the equal length because the radius is already 2 given for the circle. Also notice this is an octagon. So each angle or each, suppose I want to say like this. If I ask you what is the angle A1O A2, means any two consecutive vertices are making equal angle at the center. So that angle will become always pi by 4. Not only this, if you take A2O A3, that will be also pi by 4. But if I have to choose the point P, if I choose exactly symmetrical here, that point P must give you the maximum product of this quantity. But suppose I'm not taking symmetrical. If you take symmetrical, this angle will be automatically pi by 8. Suppose I'm not that much observant, and then I'm choosing their P only here. Now, you notice that suppose I just join this P to O, and I'm calling this angle, let's say, alpha, and this angle theta. So one thing is for sure, that the theta plus alpha is pi by 4. Now what I'm going to do is a little bit messy picture I'm going to draw, but you understand. The first thing I have to find out PA1. So PA1 is this picture. If you just see this, PA1 is actually one of the side of this triangle POA1. Okay. Similarly, if I have to find PA2, I will take PA2O in a triangle. So let's use this triangle, and in this triangle I'm using the sine rule in a different way. Let's see how. In triangle POA2, you notice the OP and the OA1, sorry, OA2 are 2 actually, because they are radii of the circle. And in this triangle, I can use the sine theta or the sine rule in this way. If I join PA2, it will make a triangle here. You understood? Complete OA2P. So this I can write it as sine theta divided by, okay, so let me write side over the side sine theta. So I can write PA2 divided by sine theta, and I'm using one of this angle. Which angle? Let me call it the OP length, and divided by angle PA2O. But notice one thing, that the triangle POA2 is an isosceles triangle. If an isosceles triangle, then we can use some different concept. What we can use different concept? Suppose I assume this angle, okay, don't assume, let's say. So I can write angle PA2O. This is a triangle, let me draw it. In this triangle, this angle I'm talking about and this angle, they both are equal. So angle PA2O, twice of it plus theta, I can write as 180 degrees, or maybe pi, because I'm working in pi by 4 and all. So this angle I can write as angle PA2O as pi minus theta over 2. That is pi by 2 minus theta over 2. All right. Now, from here, what I'm going to do is I'm using this thing. By the way, there's a sine of this. So please be clear on it. This is a sine of this angle. So can I write the PA2 as OP, that is 2 times sine theta divided by the sine of pi by 2 minus theta by 2, that is cosine of theta by 2. And we simplify this further, so we get it what? Twice of sine theta by 2 cosine theta by 2 by using the double angle formula, and cosine theta by 2 or the half angle formula, whatever you want to say, and that will give you 4 sine theta by 2. Now this story repeats for every such side. How? So PA2 I got 4 sine theta by 2. So this I save it, and I want to convince that this story will repeat for everyone. How it will repeat? Let's see. Suppose I want to find out PA3. Please understand, I'm going in this anti-clockwise, and for alpha I will do the other calculation. So suppose I want to find PA3, so I will join this P to A3, and it will again create a new triangle in which OP and O3 are equal. But you notice the angle theta will now exceed by pi by 4 because you're adding pi by 4 this theta. It means at the place of theta, I will replace what? Because theta is now pi by 4 unit ahead, so I can replace theta by pi by 4 plus theta. And the story will be the same. It means what we can write is PA3 will be 4 times sine of theta plus pi by 4 and by 2. So this will become pi by 8. Let me write it clearly. I don't know whether it is visible or not clearly. So PA3 is 4 times sine of theta by 2 plus pi by 8, because I'm replacing theta with pi by 4 plus theta. In a similar way, if you proceed ahead, I will have PA4. You notice PA4, the theta is now exceed by pi by 4 plus pi by 4. That will give you pi by 2. So can I write PA4 as 4 times sine of theta by 2 plus pi by 2? Okay, because we are actually substituting theta with pi by theta plus pi by 2. So that will become pi by 4 rather, not pi by 2. So we are making the half of it. Okay. Similarly, the last one in this anti-clockwise direction, if you go this triangle, I can use this one. So again, this radius and this radius are equal, and we are taking this angle. So again, theta will be replaced by the PA4. What we can write? PA5 now. Sorry. So PA5. Oops. PA5 is now 4 times sine, and now theta plus 3 pi by 4. So this will become theta by 2 plus 3 pi by 8. So these are the 4 values here on the anti-clockwise direction. Similarly, you see, because these triangles we are using and the lengths we are using, they are positive quantities, so we don't have to bother about the sign of the angle. So we are actually using always the positive sign of the angle. So now here what we do, the first will be this triangle, PA1, then PA8, then PA7, then PA6. Already we have found PA5. So you notice each of this theta, whatever I have found before, will be replaced by alpha, because the same thing or the same kind of calculation we are going to do in the clockwise direction in terms of alpha, because this is alpha and this will become alpha plus pi by 4. So can I write this thing as PA1 is what? 4 times sine alpha by 2. Then PA8 is 4 times sine of alpha by 2 plus pi by 8. And you understood the point. It means if I have to find it out, the product of these all quantities, I will just multiply all these values. So let's multiply them wisely. So how do we multiply? Let's call the product here. So the product, what we are going to evaluate, you notice there are some other quantities I have left over, but you can notice that the other quantity will be replica of these two values. At the place of theta, I have to place value the alpha only. So I'm going to do this thing. How? I will write, see that. So in each of this quantity, I have a 4, 4, 4, 4. So I have again 4, 4, 4, 4. So there are 8 different quantities. So we get 4 to the power 8. So it'll be 4 to the power 8. And now I am writing sine theta by 2. Sine theta by 2 plus pi by 8. Then sine theta by 2 plus pi by 4. Sine theta by 2 plus 3 pi by 8. Now again I'm writing the alpha version of it. So sine alpha by 2 here. Then sine alpha by 2 plus pi by 8. Sine alpha by 2 plus pi by 4. And sine alpha by 2 plus 3 pi by 8. But notice one interesting fact here. Each alpha you can replace with pi by 4 minus theta, because already we have taken theta plus alpha is equal to pi by 4. So alpha we can replace with pi by 4 minus theta. So can we evaluate easily? So let's just replace these values here. So replacement, I'm going to do it here. So this is going to be replaced. So I'm just making this thing in a bracket so that it is not useful further. So what I'm going to do is sine of pi by 4 minus theta. So it'll become pi by 8 minus theta by 2. Now this will become again. So why not we can directly write pi, what is alpha by 2? So alpha by 2 will become, alpha by 2 will be pi by 8 minus theta by 2. So that will be convenient. So I can write here pi by 8. So alpha is, by the way, pi by 8 minus theta by 2. So that will become directly sine theta by 2. This is pi by 8 minus theta by 2 and plus pi by 4. So pi by 4 plus pi by 8 will become 3 pi by 8. Become sine of 3 pi by 8 minus theta by 2. And again here, pi by 8 plus 3 pi by 8, that will become 4 pi by, that is pi by 2 minus theta by 2. So sine of pi by 2 minus theta by 2. So in this way, we have to club these values, these total up to here, and these total I have to club. By the way, there is one mistake here. I am substituting this alpha by 2. This with alpha is equal to pi by 8 minus theta by 2 here. So that will become pi by 8 plus pi by 8, pi by 4. So sine of pi by 4 minus theta by 2. So that will be now a little bit better. So what I'm going to do is I am multiplying this value sine theta by 2, and that will become cos theta by 2. So I'm combining this term sine theta by 2 with this term, and of course that will be giving you 4 to the power 8 sine theta by 2, and this is cos theta by 2. Let me write it first. Sine theta by 2 into cos theta by 2. Now I'm combining this sine pi by 8 minus theta by 2 with sine pi by 8 plus theta by 2, and the formula you know very well, the sine a plus b into sine a minus b is sine squared a minus sine squared b. So this I can write as sine squared pi by 8 minus sine squared theta by 2. Similarly, I can combine these two, sine pi by 4 plus theta by 2 and sine pi by 4 minus theta by 2. So that will give you sine squared pi by 4 minus sine squared theta by 2. And finally, we can club these two, sine 3 pi by 8 plus theta by 2 and sine 3 pi by 8 minus theta by 2. This is already clubbed. So what I'm going to get here is this one. Let me just take this thing down a little bit here. And then I'm clubbing these two. So I'll get sine squared 3 pi by 8 minus sine squared theta by 2. Now these things we have to calculate. So it's not difficult. We have done this kind of things many times. This I can write to the power 16. And I can divide by 2, and this I can write sine theta. Sine square pi by 8. We don't know the value of sine square pi by 8, but we know that sine square pi by 8 can be written as 1 minus cos 2 theta, that is cos pi by 4 by 2, and minus sine squared theta by 2. Here again, sine square pi by 4 we know very well, that is 1 by 2 minus sine squared theta by 2. And this is again 1 minus cos 2 theta, so 3 pi by 4 by 2 and minus sine squared theta by 2. Now notice one important thing. This can be to the power 15. That's not so important, but the important is here. What this is, I can write here 1 minus cos pi by 4. I'm not writing the value of cos pi by 4. And then minus 2 sine square theta by 2 divided by 2. Similarly, this I can write 1 minus 2 sine square theta by 2 divided by 2. And this is also 1 minus cos 3 pi by 4 will become cos of pi minus pi by 4. That will become 1 plus cos pi by 4. And minus 2 sine squared theta by 2 divided by 2. You notice one important thing is here, that is 2, 2, 2. These 3 2's will cancel and we'll get here 12. So 2 to the power 12 cosine theta. And now this is going to be 1 minus 2 sine square theta. 1 minus 2 sine square theta is cos 2 theta. So I can write here cos 2 theta minus cos pi by 4. And notice this is going to be cos 2 theta plus cos pi by 4. And this is nothing but cos 2 theta. Or rather, this is theta by 2, sorry. So this will give you not 2 theta, just theta. Sorry for that. This is cos theta, this is cos theta, this is cos theta. All right. Now again, you notice this is going to be a plus b, a minus b. So this is 12 to the power 12 cosine theta. This is cos squared theta minus cos squared pi by 4. And this is cos theta again. So we got it here to the power 12. And again, cos theta and cos squared theta is, cos squared pi by 4 is 1 by 2. So 2 cos squared theta minus 1 by 2, and then again cos theta. So we get it here to the power 12, so to the power 11, cos theta, again cos theta, and again cos theta. This is sine theta, sorry. This is going to be sine theta. This is again sine theta here. And so this is going to be, notice here, sine theta and cos theta. That will become 2, sorry. Okay, let me write it this again. This will become to the power 12. Sine theta into cos theta will become sine 2 theta by 2. And this 2 cos square theta minus 1 is cos 2 theta. And that was by 2 already. So this will give you to the power 10 sine 2 theta cos 2 theta, and then again we divide and multiply here, so it will become to the power 9 sine of 4 theta Now, these all theta are positive quantities. So I can say this magnitude they can take r. So when this thing is maximum, when this entire quantity will become 1. So the max value is going to be to the power 9, as our sine 4 theta is going to be 1. Therefore 4 theta, you can see this is pi by 2. So theta was pi by 8. So in the beginning, when I started the question, I told you that the maximum value will be achieved when the P is exactly in the middle of this arc, so that this angle made here is pi by 8. So in this way, by using the trigonometry, we can also solve this question. Maybe this question solution is very lengthy and it's not recommended for the examination, but if you're preparing for this kind of competition, you must know some multiple ideas. And it's also satisfactory because we are using the trigonometry, because I believe that by looking at the question in the first glance, we have no idea about the complex number involved there. Although you have a good practice on those kind of cube roots of unity questions, you must identify this the question of complex number. But in rare case, if you are not identifying it, maybe this is the correct approach, or maybe the quick approach to start with. And if you are enjoying those kind of things by looking into the solution or looking into one solution in different approaches or different ways, I think you will give a thumbs up to this method also. So see you in the next video with some other such questions, with other some unseen solutions. Stay math active.